Hello, and welcome to an introduction to forecasting. So, today we're mainly going to focus on the process of forecasting so that you've got a solid understanding of the fundamentals that you'll need to do every time, no matter what fancy or complex forecasting method you're going to use. So the things we're going to go through are the steps in the forecasting process, how to explore and visualize your time series data, how to create simple forecasts using benchmark or what we call baseline methods, how we measure the accuracy of our forecasts, and we're going to look at an advanced forecasting method to compare to our benchmarks called exponential smoothing. And we're also going to figure out how do we choose which is the best method to use for our particular forecasting problem. So there's 3 Python labs, practical labs for us to do to get through this. One of those will be about exploring time series data. We'll have one on benchmark and baseline methods and measuring forecast accuracy. And the final one, which may be a challenge to get to, is one on exponential smoothing and comparing to baseline methods. But before all that, we're going to have an introductory lecture and we're going to talk about what can we forecast? What are the things that we can forecast? What is the process of forecasting? And we're going to have our first look at time series data and how we understand it. So before we say anything else, I just want to warn you that forecasting is difficult. It is very difficult to get an accurate forecast and to understand the uncertainty in your forecast. And that's because there is no way to tell exactly what will happen in the future. But what we can do is make inferences about that. And the statistical forecasting approach that we're going to follow is going to help us do that in the most robust way possible. But under no illusions, this is not an easy thing to do. So what are the steps in a forecasting project? Well, a lot of the initial work will be about the problem definition. So understanding what it is people need to forecast, how often they need that information, what type of data they have, and things like that. And we'll talk a bit more about that in a second. There'll be a small amount of data collection. In most projects, it will be fairly straightforward. But some data may be highly complex and there may be lots of it as well. But for most business type applications or operations type, it should be fairly straightforward. Then there'll be a process of exploring your data, fitting models to it and selecting different models to try, and then evaluating which of those models is the best for your forecasting problem. So those final 3 stages are the bits we're going to explore in detail with Python today. So what can be forecast? Well, we've got some examples here. We've got call volumes, so call centers and demand type problems are often things which require forecasting. So for example, in a call center, you want to know how many staff you should have on at certain days in the future. So you'll need to figure out what your demand is going to look like. Many businesses require to understand what their orders are going to look like so that they can manage their inventory. You might want to know how many types of a different type of product are you going to sell. There may be large numbers of these time series that you need to predict. Electricity demand is another classic forecasting problem. So what is electricity demand going to look like tomorrow, the day after, and the week after that? And then finally, how is a disease going to spread across a country? A very topical one at the moment. So there may be many different ways of doing that. And I think the methods we're going to be looking at today aren't the right ones for this task. But it's worth knowing that you can predict how diseases spread and forecast it. So with all of these problems, there'll be a forecast horizon. And that's always worth bearing in mind. So how far into the future do you need to forecast? Is it minutes, hours, weeks, months, or years? And depending on the problem, the further forward into the future you go, the more difficult it is to be able to predict what is happening. So the general experience of forecasters is that some things are definitely easier to predict than others. So that is usually contributed to by three things. So how well do we understand the factors that contribute to the thing we're trying to forecast? So for example, we talked about call centers. So we might, if you're in a call center for a shop or a distribution network, then you'll know that there'll be peaks at different times of the day. So there's an hourly pattern within your data. So for example, there may be a peak following the end of work, the normal working day, so around 6 p.m. Data definitely makes a difference to how accurate your forecast will be, and it also makes a difference to what type of methods you can use. If you're trying to predict sales, you may not have any data at all. So it may be a brand new product that you're launching. In those cases, you'll need to use something called judgmental forecasting. We're not going to look at judgmental forecasting today. We're going to focus mainly on quantitative approaches. And the more quantitative data you've got, usually the better. Although you might find the longer back in time you go, the less relevant the data to the current forecast. So there may be breaks within your data where there's been structural changes within the system that you're working with or within the demand that you're looking at. But the thing that really throws forecasts out is whether predicting something leads to an action that affects that forecast. So for example, if you're predicting where crime might happen, you might send police officers out to that location, and their presence there may reduce the likelihood of crime. So you can never really tell if your forecast was accurate or not. So let's think about problem definition in the forecasting process. So a common question is, I would like to know, is it possible to forecast whatever, insert your favourite thing? This is the wrong question to be asking. So if a client asks you that question, then there are a number of responses you need to give. So the first of which is to ask them, what are the decisions that the forecasting will support? And that usually falls into three types of category. So they might be short-term decisions that are operational in nature and might be around scheduling of resources, for example, staff. Or it might be medium-term, and those are usually about resource requirements. How much resource will we need at some medium-term future date? Longer than that, then you're really talking about strategic planning. And that might be forecasts over a number of years into the future. A big question is, how many time series do they need to forecast? Is it one or is it many? Because that dramatically changes the type of analysis that you can do. If it's many time series, then what you're really talking about is a forecasting at scale problem. And in that case, you really need to turn to automatic methods to select your models and do the forecasting. So that, for example, could be like a problem at Amazon where they need to forecast the sales of multiple product lines. Or it might be a geographic problem where you're trying to predict a type of demand across many regions. And of course, those regions may have some sort of correlation amongst them. So a simple answer to the question of, I'd like to know if I can predict something in the future, is just take the average. But that doesn't mean that that's an accurate way of forecasting. So what you really should be doing is trying to understand the needs of the client in terms of what level of accuracy is needed to support their decisions. And that's going to become harder if they want to forecast further ahead into the future. So the farther you go into the future, the more uncertain you will be and the less accurate your forecast will be. You'll be interested about what type of data they've got. So for example, how often is that recorded and what frequency? So it might be, in some cases in medical applications, recorded every second, or it might be recorded every hour or week or monthly in more operational type decisions. And then lastly, what you need to know is how often are these forecasts needed? And that's going to vary depending on what type of decision is being made. So if it's strategic decision making, then it's likely that's a one-off forecast, or it's a forecast run once a year. But if it's short-term operational, that might be something that's run every day or every week, and in which case you'll need to start thinking about automation of your forecasts. So make sure you spend time with your clients, talking to them about what their needs are and how they're going to use the forecasts that are produced. Don't do any analysis and modelling until you've spoken to them. So in this course, we're going to focus on time series forecast. And we'll have a look at a time series in a moment. So most quantitative forecasting that you'll see is using time series data. So that might be something like the daily number of views of a film on Netflix, or the monthly number of patients that are conveyed by ambulance to an emergency department, or quite topically, the quarterly sales of toilet rolls in the UK. So as I said, you can't predict exactly what's going to happen in the future. So what time series methods do is they learn the patterns within your data or make assumptions about them and assume that those historical patterns will continue into the future. So unfortunately, there are cases where this doesn't work. So extreme events in human history will break this assumption. And that's a problem we've got at the moment. So let's take a look at some time series. So here we have a time series plotted over time of beer, wine and distilled alcoholic beverage sales. So take a look at this picture and pause the video for 2 minutes and write down a few bullet points about how you would describe this data. How would you summarize it? What would you do? And then when you've done that, start the video again and I'll talk you through it. So what's going on in the alcohol data set? So there were 333 ordered observations and they were collected at a monthly level frequency. They were quantitative data and they represented the sales of beer, wine and distilled alcohol beverages in millions of dollars. And the data was collected between January 1992 and October 2019. There was definitely an upward trend in the data, so the data increased its mean level over time. Now it's a bit unclear if that was a linear increase or if it was non-linear. and that's something we'll take a look at later in the course. So the mean of the data increased over time due to the trend. And another interesting thing was that the spread of the data, what we call its variance, also became bigger over time. So the fluctuations in the data grew as the data went from January 1992 towards October 2019. Now, from the picture, we might suspect there was also something called seasonality. So there was some predictable seasonal fluctuations in there. But I put a question mark by that because we really need to use some quantitative methods to check if that's what's going on. So I didn't do anything clever there to write that down. I just followed a standard checklist of things that you would use with time series data. So whenever you see time series data, you need to think about trend. Is there an upwards or downwards leaning in the data? And seasonality. Are there predictable seasonal fluctuations within the data? So those fluctuations might occur at a weekly level, a monthly level, an hourly level, a yearly level, and so on. What about the mean of the data? What's the mean and its variance? How do they change over time? And then some more complicated time series specific things are called stationarity and autocorrelation. So here's another example of a time series. And let's think about those characteristics we just talked about. So the mean of the data is about 30. And it looks like the data varies roughly between 25 and 30 most of the time. There doesn't seem to be any trend in the data, so it's not going up or down over time, but it does seem to randomly fluctuate. And it's not clear if there's any seasonality in the data. So this type of data is called stationary data. So if we took any particular chunk of this time series, the properties we observe, such as the mean and the variance and the trend, do not depend on that particular chunk we've taken. So time series, so that follows that any time series with a trend or seasonality is non-stationary data, a non-stationary time series. And that's a key characteristic of time series. And generally, stationary time series are easier to forecast than non-stationary. Here's a more complex time series. So in this case, we've got emergency department performance. So emergency departments for a long time, although it may change, have been measured on something called their 4-hour performance. So the proportion of patients that enter the department and leave within 4 hours. So it looks like in winter 2014, there's a break in the time series, and the time series has changed direction. So prior to that winter break, there's possibly a stationary time series, or maybe 2 levels within it. So maybe there is a decreasing trend in that part of the time series. But certainly post-winter 2014, the downward trend in performance accelerates. So performance gets worse. There's also a clear difference in the variance in the data. So the variance has increased over time. So as the mean performance has got lower over time, the variance in performance has increased dramatically in some cases. It also looks like there's some clear seasonality in the data, where we can see that winter months tend to perform worse than summer months. So all these characteristics help us with a statistical perspective on forecasting. So by taking all of these things into account, forecasting methods are able to generate data that follows those patterns in the future. So here we've got a classic data set from the forecasting literature. So it's forecasting the number of airline passengers every month between, well, the data runs from 1949 to 1961, and then we forecasted 4 years into the future. So where's my marker? So this here is what's called the training data. This is historical data of what actually happened. This data is our forecast. So we can see a blue line, and the blue line represents the most likely value that our forecasting method thinks this data will take. And then around that, we've got some measure of uncertainty. So these yellow and pink shaded areas represent what are called prediction intervals. And those help us understand the likely range that forecasts might take, as well as the most likely value. Now, what we can see is that the forecasting method has been able to take into account some of the characteristics of this time series and project them forward. So, for example, we can see there's an increasing trend over time in the number of airline passengers, and our forecasting method has used that going forward. We can also see that there are some clear seasonal fluctuations over time, and our time series method has used that again to generate our forecasts. And then finally, we can see that the seasonal fluctuations in the time series grow as the mean level of the data grows. And that's exactly what happens in our forecasts. So we can see that the seasonal fluctuations after 4 years of our forecast are much bigger than at the beginning of our forecast. And that follows the pattern that we've seen within our data. So we're going to now go on to some Python exercises. So we're going to learn how to explore our time series data using Python. We're going to learn about how to make baseline or benchmark forecasts with Python. And then we're going to learn about exponential smoothing. And there's quite a lot of detail to get through all of this. So there are a number of lectures that we're going to go through. And it should be fun. See you soon.